Hello everybody, this is Mr. McNair, and this is a video over the things that we learned in Chapter 7. What I'm going to do here is I'm going to put up the answer key to the review that we did in class. It came from page 510 in the book. I would suggest you go ahead and go through some of the problems, give them a good try, and then you could pause the video in certain segments so that you can see what the answers were. So here's the answers for problems 1 through 10. Here's the answers for problems 11 through 21. And remember, you could pause it at any time. Here's 22 through 31 and 32 through 34. Now, what I've done is I've picked out a couple of problems that I think are representative of each section, and that will help you prepare for the retake quiz that'll be coming up. So here's problem number 3. Find the GCF of each pair of monomials. First thing that you want to do is you want to look at the coefficients, 15 and 9. Between 15 and 9, you want to look at the numbers that divide evenly into those numbers. Numbers that divide into 15 are 1, 3, 5, and 15. The numbers that divide into 9 are 1, 3, and 9. And because we're trying to find the GCF, that's the greatest common factor, what you want to look at is find out which one of these factors is the greatest. Well, the greatest common factor between 15 and 9 is 3. So that'll be the coefficient part of our GCF. Next, we're going to look at the variables, into the fifth and into the fourth. Now, what you want to look at when you're looking at the variables is what is the most amount of variables that I could take out of both. Now, the number has to be the most amount of variables that you can take out of both. They have to be the same amount. For example, here you have 5 n's. Here you have 4 n's. All right, you want to take the same amount of n's out of both of them, and you want to take as much as you can. So that would be n to the fourth. All right, I look at it and think of it as like this: if I have a person that has $5 here and a person that has $4 there, and I want to steal from both of them, okay? I'm not justifying stealing, but if I want to steal from both of them and I want to steal the same amount from both of them, and I want to steal as much as I possibly can, how much can I steal from both? Well, the most I can steal from both of them is 4. So our answer overall is 3n to the fourth. All right, number 4. This says write the prime factorization of 360. The way that I start these problems off is I make a factor tree. All right, pick two numbers that multiply together to give you 360, such as I'll use 60 times 6. All right, and then from there you just keep on finding numbers that multiply to give you the product that you're looking for. 6 times 10 gives me 60. 2 times 3 gives me 6. And you stop when you get to prime numbers. 6 multiplies, you can get a 2 times 3 to give you 6. You can get 2 times 5 to give you 10. 2 and 3 are already prime. And now we're left with all prime numbers. Okay? Now that you have the all prime numbers, notice that we have 1, 2, 3 2's. So I'm going to write that as 2 to the third. We have 1, 2, 3, so I'm going to write that as 3 squared, and we just have 1, 5. So the prime factorization of 360 will be 2 cubed times 3 squared times 5. All right, this problem, number 5. A coin collector is arranging a display of 3 types of nickels. The types of nickels and number of each type are shown in the table. The collector wants to arrange them in rows with the same number in each row without having any different types in the same row. How many rows will she need if she puts the greatest possible number of nickels in each row? So let's look. We have these 3 types of nickels, and we want to put the same number of nickels in each row. All right. So considering that we have 16, 24, and 40 nickels, and she wants to put the greatest possible number of nickels in each row, what's the GCF between 16, 24, and 40? What's the greatest number that goes into all 3 of those? Well, that would be 8. Okay, so you could put 8 nickels in each row. So if you could put 8 nickels in each row, how many rows of the Liberty would you have? You would have 2. How many rows of the Buffalo? You would have 3, because 8 goes into 24 3 times. How many rows of the Jefferson? 5, because 8 goes into 40 5 times. So how many total rows do you have? 10. So there would be 10 rows of nickels. All right, now we're going into the general factoring. This one, they want you to factor the expressions. Let's look at number 6. First thing, when you factor the expression, you want to look and find the GCF. The GCF between 24m squared and 4m cubed. Well, the greatest number you can take out is 4. The greatest amount of variables is m squared. So we take that, and then we divide it out of each of them. 24 divided by 4, that's 6. You had 2 m's. You took both of them out, so there's no m's attached to the first place. 4 divided by 4 is 1. But we don't need that 1 there. And you had m cubed. You had 3 m's. You took 2 of them out. So we're left with 1 m there. And that's factored. Here, you're factoring out the common binomial. You could take a c minus 5 out of both of these terms. So if you take a c minus 5 out, that would factor out, and that would leave you with 3 plus 4c left. And that goes into the next parentheses. All right, next. Whenever you have 4 terms, you should automatically know that you're going to be factoring by grouping. When I have 4 terms, I usually like to have a plus sign in the middle, so I'm going to change that to plus a negative 25x squared. So when you factor by grouping, you group the first 2, group the last 2, and then you factor out the GCF out of both sets. The GCF out of the first set here would be 2x. Left on the inside, when you divide that out, you get 5, because 10 divided by 2 is 5. And then you had 3 x's, you took 1 out, so there are 2 x's left, so that's x squared. Same thing here, you're going to divide out the 2, so 4 divided by 2 is 2. You had 1 x, you took it out, so there's no x's left. And then here, between negative 25 and negative 10, you could take out a common negative 5. All right, if you divide out a negative 5, what will be left is a 5x squared plus 2, because negative 10 divided by negative 5 is positive 2. Now, one thing that is important and crucial is that whenever you are factoring by grouping, the 2 parentheses must always be the same. If they're not the same, you've done something wrong. Now what you want to do is the same thing that you did in this previous problem over here, where you factored out the common binomial. You're going to factor out the common binomial here. You're going to take out that 5x squared plus 2. That's why they have to be the same. And then what you have left is a 2x minus 5, and that goes in the last parentheses. Okay? Always check to make sure that it's completely factored. All right, here we're going to factor trinomials. So always look to see if you can factor out a GCF first. In problem number 13, you can't. We see that here a is 1, a is the number in front of x squared, b is 6, b is the number in front of x, and c is 5. 5 is the constant. When a is 1, what you're looking for are 2 numbers that multiply together to give you c, but at the same time add together to give you b. Okay? Numbers that multiply together to give you c, here they're 5. The numbers that multiply to 5 are 1 and 5. And they happen to also add together to give you 6. Okay? So this factors out to be x plus 1 times x plus 5. And this is your answer. Now, what is wise for you to do is to check your answer. You could check your answer by foiling. And I'm going to go ahead and foil this one. I'm not going to foil the rest of them. So just so you know, this is how you foil. First, outside, inside, last. So we get x squared, add your like terms. So because this answer is the same as what we started with, we know that our answer is correct. So our answer, once again, this is the answer. That's the answer. Okay? Let's do the same thing here in number 14. Here, there's no GCF to factor out. So a equals 1, b equals negative 4, C equals negative 21. Once again, we're finding two things that multiply to give you C, and at the same time add to give you B. The things that multiply to negative 21 and add to negative 4 are negative 7 times positive 3. So that's going to be x minus 7 times x plus 3. And it doesn't matter what order you put that in. If you wanted to, you could have put the x plus 3 on the other side. Okay, doesn't matter. All right, let's move on. Here, factor each trinomial. First thing again, we're going to look and see if we can factor out a GCF out of all of those. There is no common number that comes out. So here, a equals 2, b equals 9, and c equals 7. Now when a is not 1, you can use two different methods. Either you're going to use the guess and check method, or you're going to use the AC method. Because most of my students do the AC method, I'm going to go ahead and do that here. AC method, you multiply your a and c together. So when you multiply that, you get 14. Now we find two numbers that multiply to give you 14, but at the same time add together to give you 9, the b. Okay? So two numbers that multiply to 14 and add to 9 are 2 and 7. Alright, so after you have these two numbers, you break up the b. And the breakup of b looks like this. You're going to rewrite your trinomial, 2x squared, and then you're going to bring in your two factors, 2x now and 7x, and then we're going to bring down that 7. Alright, the reason why we have the x attached is because up here we want to get 9x. So when we broke up b, we put an x with those. Okay, now you have four terms. You're going to go ahead and factor by grouping, just like we did in a couple problems ago. So you're going to group the first two, group the last two. What is the GCF of the first set? Well, that's 2x. So that leaves you in first position with just x. And then here, 2 divided by 2 is positive 1. So there that is. The GCF of the second set of parentheses is a positive 7. And once again, that leaves you with x plus 1. All right? These two parentheses, they're the same. They always need to be the same when you're factoring by grouping. If they're not the same, you've done something wrong. So you're going to factor out that common binomial, and then what's left on the outside is a 2x plus 7. All right, once again, you can FOIL that just to make sure that you get your original answer. All right, this problem, this is similar to the last one. However, one thing that I would suggest you do is to never have an a that's negative. All right, so what we did in class is we factored out a negative 1 when a was negative. All right, so if you factor out a negative 1, in first position you'd be left with 3x squared, and then you'd have a positive 2x, and then a minus 8. Okay, we just factored out negative 1. Now you can do your a, b, and c. Here a is 3, b is 2, c is negative 8. Once again, we're going to do the AC method. So we multiply a and c together, and we get negative 24. What multiplies together to give you negative 24 and adds together to give you positive 2? Well, that is positive 6 and negative 4. So we're going to use these two numbers to break up that b. Okay? So we're going to have this 3x squared. We're just going to bring that down. And then instead of 2x, we're going to bring in our factors, positive 6x and negative 4x. And then we're going to bring down that minus 8. This negative 1, I'm not going to worry about it right now. I'm just going to leave it there, and then I'll drop it down at the end. Okay? So now we have these four terms again. We're going to factor by grouping. Group the first two. I'll make that plus and negative. Group the last two. What's the GCF of this first set? Well, the common number that comes out, the greatest common factor, is 3 and an x. So what's left in first position? Well, that would be an x here, and then a plus 2. Again, we know that this parentheses and whatever parentheses we have here have to be the same. So what I would suggest then is to take out a negative 4. When you divide out negative 4, you get an x for the first position. And then negative 8 divided by negative 4 is positive 2. So now once again, we see that this parentheses and this parentheses are the same. If they're not the same, you've done something wrong, right? So you have your x plus 2 there, and then on the outside we were left with this 3x minus 4. Now, be careful here, because you don't want to forget that we took out this negative 1 at the beginning, so you have to bring it down. So now we have this negative 1 here on the outside, and that is our final answer. Okay? Moving on, number 22. This one, these patterns are that you're looking for in these problems when you have just two terms, specifically, is the difference of two squares. The difference of two squares pattern. And the pattern goes like this. If you have two perfect squares that are being subtracted, that's why it's called a difference, then what you would do is you take the square root of the first one and you put it in the first position of your two parentheses. You take the square root of the next one and you put it in the next position of both parentheses. And then one becomes a plus, one becomes a minus. Simple as that. All right, let's look at problem number 23. Here, you also want to do the same thing. You might look at this problem and say, oh, this isn't the difference of two squares, but always be careful. Is there a GCF you can factor out of both of these? Well, yes, both of them you could take out a 5. So what will be left is 5y squared minus 2. Is there anything else we can do? Is this the difference of two squares? Well, 5's not a perfect square, and neither is 2. So actually, you are done in that problem. That's it. All right, let's take a look at number 24. 24 here. Is 9a squared a perfect square? Yes. Is b to the 10th a perfect square? Yes. Are you subtracting? Yes. So let's do our pattern. You put your two parentheses here. You take the square root of the first one. The square root of 9a squared is 3a. Okay? And then the square root of b to the 10th, that's what? B to the 5th. One becomes a plus, the other one is a minus. And there you go. That's your answer. Okay? Let's move on. Here, a company is producing square sheets of plastic. Each has an area of 9x squared plus 30x plus 25 feet squared. The dimensions of each sheet are of the form ax plus b, where a and b are whole numbers. Find an expression for the perimeter of a sheet. Find the perimeter when x equals 4 feet. Well, first thing, let's talk about the fact that we know that this square sheet of paper, or square sheet of plastic, is a square. So that means that all the sides are the same. And we know that the area is 9x squared plus 30x plus 25. All right, from there, what I would do is factor your area. Okay, so if you take your 9x squared plus 30x plus 25, there's no GCF that comes out of all of them. So here, A is 9, B is 30, and C is 25. Now, I gave you guys a big hint when we were in class. If you notice that A is a perfect square and C is a perfect square, I would suggest that you factor it by the guess and check. All right, go ahead and put your parentheses in there and allow your first position to be the square root of your A. So the square root of 9x squared is 3x. So put that in first position. The square root of 25 would go in the next position. Okay? And the square root of 25 is 5. Now, because this totals up to 30x, your inner and your outer have to add up to 30x, you want to make these both positive 5s. Now, guess and check, remember, is guess. This is our guess right here so far. That's the guess. To check it, you have to check that your outer and your inner When you multiply them together, their sum is 30x. 3x times 5 is 15x. 5 times 3x is 15x. That adds up to 30x. So that is the correct factorization. That means that this side here is 3x plus 5, and this side here is also 3x plus 5. Now, this problem has two parts. It says find an expression for the perimeter of the sheet. So the perimeter is when you add up all the sides, right? So if this is 3x plus 5, this is 3x plus 5, this is 3x plus 5, and this is 3x plus 5, well, let's go ahead and add all the like terms. 3x plus 3x plus 3x plus 3x. Well, that's 12x. 5 plus 5 plus 5 plus 5. Well, that's 20. So that's an expression for the perimeter. Now, the second part says find the perimeter when x is 4. So all we have to do now is take our expression for the perimeter and plug 4 in for x. So 12 times 4 plus 20. 12 times 4 is 48. 48 plus 20 equals 68. So that's 68 feet. Okay, moving on. Factor each polynomial completely. Once again, you always want to look for a GCF that comes out of all of the terms. Here, a GCF of 8 comes out of all the numbers, the coefficient, and you could also take out an x. So that leaves in first position an x squared, then a 9x, and then 8 goes into 160 20 times. So now you know that A is 1, B is 9, and C is 20. Remember, when A is 1, only when A is 1, you use what multiplies to C and at the same time adds to B. Well, what multiplies to 20 and adds to 9? That's 4 and 5. So that's x plus 4 times x plus 5. And then don't forget, what you factored out comes down and attaches to the end. All right, number 30. Looking at these two, is there a GCF that comes out of both? Well, you could take out a 3 out of both of the numbers, and you could take an x cubed out of both of the variables. So in first position, you're left with x squared minus 9. Now, a lot of students would think they're done here, but this pattern right here is the difference of two perfect squares. So we need to factor this. So in the difference of two squares, you put your two parentheses there. The square root of the first one goes in first position. The square root of the last one goes in the last position. One becomes a plus, one becomes a minus, and then you drop down your GCF. All right. Next, again, we're going to be factoring by grouping. You could do this one in a couple different ways. You could look through all of these and factor a GCF out of all of them. The GCF that comes out of all of those terms, it looks to me to be 4. So you could take a 4 out. All right. If you did that, what would be left in the first position? Well, that would be 2x cubed. And then you'd be left in the second position with, 16 x squared. And then next position would be 5x. And then this one would be 40. All right. Now again, you still have 4 terms in here, so you're going to factor by grouping. Group the first set, I'll make that a plus negative, group the last set. I'm going to forget about this 4 for right now, I'll just drop it down at the end. So, what's the GCF of the first set? Well, you can take out a 2 and an x squared, leaving you with an x plus 8. What's the GCF of the next set? Negative 5, leaving you once again with an x plus 8. We just divided that out. Once again, these two parentheses need to be the same. So we factor that binomial out. And what was left on the outside is 2x squared minus 5. And then, of course, at the end, you're going to bring down that 4, that GCF that we factored out at the beginning. So there's our answer. All right. Almost done here. 2 more problems, I believe. Next, once again, you're going to factor out your GCF. Here, notice that you have a c and a c to the 7th. So, you could take a c out of both of those. Here you have a d to the 4th and a d to the 6th. So you could take a d to the 4th out of both of those. So what's that leave you with in the first position? Well, you took the whole thing out. So that just leaves you with 1, because anytime you divide something by itself, it's 1. We'll bring down that minus sign. And then in the last position, we had 7 c's and we took out 1, so that's c to the 6th. You had 6 d's and you took out 4, so that's d to the 2nd. Alright, so we factored out the GCF. Now, notice that this, once again, is a difference of 2 squares. 1 is a perfect square, c to the 6th is a perfect square, d squared is a perfect square. So, put in your parentheses, your 2 parentheses. Put the square root of the first one in the first position. Square root of 1 is 1. The square root of c to the 6th, that's in d squared. Well, the square root of c to the 6th is c cubed. Square root of d squared is d, so you're going to put those in there. Once again, 1 is a plus, 1 is a minus, and then we're going to drop down our GCF. Now, this one, is this the difference of 2 squares again? It was close, but no, it's not. 1 is a perfect square, d squared is a perfect square, but c to the 3rd is not a perfect square. So you actually are done here. This is your final answer. All right. Last one. Here, once again, you want to look and see if you can factor out a GCF. Here, we could take out a 7 out of both of those, leaving you with m to the 8th minus 1. Again, we have a difference of 2 perfect squares. So, we're going to go ahead and put our 2 parentheses down. Put the square root of the first one in the first position. Put the square root of the last one in the last position. 1 is a plus, 1 is a minus, and I'm just going to drop down that 7. Now be careful because you're not done. Because look, you got another difference of 2 squares. So I'm going to put my parentheses in there. The square root of the first one is m squared. So that goes in first position. The square root of the last one is 1. That goes in the last position. 1's a plus, 1's a minus. And I'm just going to bring down all of this other stuff that I had before. Alright? Now, once again, be careful, because again we have the difference of 2 squares. Okay? So, we're going to take this one and break it up. The square root of m squared, that's m. The square root of 1, that's 1. 1's a plus, 1's a minus. And then I'm just going to bring down all of my other things. Do we have any other difference of 2 squares? No. All right. This is not a difference of 2 squares because m is not a perfect square. All right. And I always get students that ask, well, Mr. McNair, you broke down the m to the 4th minus 1. How come you didn't do this one? Well, remember, the pattern is a difference of 2 squares. This right here is not a difference. It's addition. Difference means subtraction. All right. So our final answer is here. All right. Hopefully you guys understood everything that was given to you. You might want to go through some of the previous lessons that we did, and have a good afternoon, a good weekend, good morning, I guess, depending on when you're listening to this. All right, bye.